Hello. Am I audible? Hello.
Yes, sir.
Okay. So just give me 2 minutes. Okay? Hello, good evening, everyone. This is Nitin from Stats team, and welcome to this session. This session is about topic wise related to week 4, and week 4 is about continuous distribution, continuous random variable. And in the first 3 weeks, we have completed the discrete random variable, the properties of random variables, discrete random variable, and then expectation and variance of the discrete random variable. Now we have moved to the continuous random variable. So I hope you already have gone through the video lectures and have seen the content of week 4. So is there anyone who haven't started watching the lectures?
Sir, I haven't started watching them yet.
Okay. So have you any idea about the continuous random variables?
Yes, some idea, sir.
Okay. So we will cover the main concepts of week 4 here, and we'll see some questions regarding that. Okay, so, whichever we have provided in the assignments, we will solve those questions. Okay, and if you have any questions, any doubts regarding that week 4 content, you can ask here. Okay, so should we start now? Okay, so let me share my screen first. Just give me 2 minutes. Okay, so let's start now. Week 5. Can you see the screen?
Yes, sir.
Okay. So first tell me what is the difference between discrete random variable and continuous random variable? What is discrete random variable?
Discrete random variable is countable and continuous is uncountable.
Countable means what? The range is countable, right?
Yes.
Yeah, range is countable, and in the continuous random variable, you can say the range is not a countable, or say it's uncountable set. Okay. This is one way to distinguish between discrete random variable and continuous random variable, but this is not the technical definition of this. The idea is very simple. Let's say if I say that x takes values, some finite values or countable values, means that if the range of x is countable, then it goes to discrete random variable, and if not countable, then this is countable. If it's not countable, or say uncountable, then the range is uncountable, then it is the continuous random variable. For example, in most of the cases, we have seen that in the Poisson distribution, right? In the Poisson, the range of x is what? Range of x is what? In the Poisson distribution, what is the range of x?
0, 1, 2, 3, 4, 5.
Yeah, 0, 1, 2, 3, right? This is we count the number of events, right? So numbers is always in the integers. So 0, 1, 2, like up to infinity it can goes, but it is still a countable set, right? Or say the binomial distribution. In binomial, what happens? Binomial, we count the number of successes in n trials, n fixed trials. Again, it is we count x takes values, integers values, from starting from 0 to n, right? It's again a finite set. Finite is always countable. or say binomial or say Bernoulli distribution, it's very easy. The here x always takes value only 0 and 1, right? Refers to success, refer to failure. This is failure, this is success. So it always takes two values. It is again a finite. So this is again a discrete random variable. So discrete random variable takes the finite values. The range of x takes the finite values or uncountable values. But in the case of, let's say I talk about the, if I'm interested in the, let's say heights of some students. Okay, this is again a random variable. This is my random variable. Here the random variable takes can take values within some finite range, right? It can take any real values, not the integers one. It can take any real values within some range. Let's say 4. It can take in between 4 feet to 7 feet or something like that. Just for example, but it can take in within this range. It can take any real number, right? So in this case, it is not a countable set, right? It is uncountable set. So here my random variable x will become continuous random variable. Okay, so the week 4 is all about the continuous random variable. This is not the technical definition of continuous and discrete random variable, but you can distinguish between these two by using this approach. Okay, this is not the definition of defining discrete and continuous random variable. Okay, so first we will define the CDF of that random variable x, and then we will go to the concept of PDF. Okay, so what we have done till now in the discrete random variable, we just define PMF, right? And then we go to CDF, right? PMF is just the probability mass function. It is the probability of each and every outcomes. It's just the functions which assigns each and every outcome to its probability, right? This is your PMF for the discrete random variable. But in what happens in the case of continuous random variable, let's say x is my continuous random variable. Okay, here probability that x will take value, any values x, is always 0, right? This is the main concept here. Probability that x will take, and why this is true, we will come while defining the CDF of a continuous random variable. So keep in mind, for a continuous random variable, p x equal to x is always 0. That is, probability at a single point is always 0. Okay, so we cannot define the concept like PMF here, probability mass function, because probability is always 0. In the case of discrete, what we do, we just assign each and every outcome to its probability. That functions we call as a PMF. But in this case, probability at each outcome or each individual point is always 0. So we don't define any concept like PMF here, but we define something like PDF. It is not the probabilities, but we get the ideas about that, because probability is always 0 at a single point. In the case of discrete random, in the case of continuous random variable.
Sir.
Yes.
So, sir,
Sir,
PMF and PDF can be considered similar, is it? I mean, they
no,
are
no,
one.
no, not the similar one. Look, in the PMF, what happens? PMF gives you the probability at a single point, at the individual points for the discrete random variable. But in the PDF, I just told that in the case of continuous random variable, probability at each point, at each individual point is always 0.
Yeah.
So we never talk about the probabilities at individual points. So PDF is something like the density around the point.
Okay, sir. Okay.
Density of the probability.
Okay.
Because the probability is always 0. So it's not the probability at that point, but something big, dense, how dense the probability is around that point.
Okay, but so CDF would be available for both PMF. I mean, the discrete.
CDF, definition of CDF is the same for both discrete and continuous random variable. Okay, so we will define the PDF just by first we will define the CDF, then we will go to the PDF concept of PDF. Okay, I'm just connecting this discrete and continuous random variable. Okay, we will come to this why this is always 0. Okay, so first tell me what is the yes.
Sir, is this only because like we can't calculate the area under the curve would be 0 because of the integration?
Yeah, exactly,
or like
some
other reason?
No, exactly. That the area, the probability gives the probability is calculated using the area under the PDF curve, right? So at that point, the area below that will always be 0. So that's why the probability comes out to be 0. right?
So that is the only reason. There's no like other reason than that, right?
Yeah, that's it. Because look at there are uncountable, right? Uncountable points or say outcomes in that random variable x. So it doesn't p x equal to 0. It doesn't mean that x will not occur anymore. It doesn't mean that. It means it. Let's say, for example, if I say my random variable is let's say experiment. Let me define first experiment. Experiment is I'm breaking a rod of 10 centimeter. Okay. Now my x I'm defining as the length of the smaller part. It will break into two parts. So a smaller part, right? So what will be the range of x here?
Less than 5.
Yeah, 0 to 5. It can be anything 0 to 5, right? So if I say what is the probability that x will be 3, or say what will be probability that x will 5. So this is continuous random variable. So probability that at 3 and 5 will always 0, but it doesn't mean that it won't be break into the smaller part of 3 centimeter or 5 centimeter like that. It may break into these parts, but the probability at the individual point is always 0. Okay. So doesn't interpret that this point will never occur. In the case of discrete, what we say, if the probability that x equal to 0, then it means that x won't occur. That is that we take the interpretation by this, right? If the probability for some point is 0, it means that point won't occur. But in the case of continuous, it doesn't mean that. It can occur. It can be in the range of x, in the, let's say, range of x, rx, or say t of x, but probability is always 0. Okay. So first let me define the CDF of a random variable x. What is the CDF? Let's say x is random variable, discrete or continuous, both discrete and continuous. Anyway, anything continuous random variable. So how do you define the CDF? Capital F.
And it's a function of the range of values that x can take between certain intervals. So it is a function, basically, cumulative distribution function.
Yeah, cumulative distribution function. So you are saying that probability is within a given interval, is it?
Yeah.
No, it's not defined like that. First, the cumulative density function defines from the real number to 0 1. Okay.
Yeah. Yes, sir.
Okay. So how do you define, let's say, f of x? X is any value. Then what is how do you define f of x?
X, all x that are less than x means all values that the variable x takes.
Yeah, probability that
Yeah.
x will takes value less than or equal to x, right?
Yes.
For any real number x. Okay. Let's say x is your Bernoulli. So what is f of -1?
0, sir.
0. Is it defined here?
No, not defined, sir.
It is defined. Cumulative density function is defined for every real number.
Okay. Otherwise 0. Otherwise, that is why we write that, sir. Right, sir?
Yeah. So what is f of let's say 0.5? So why f of -1 is 0? If you go through the definition, it will say that x less than or equal to -1, right? And in the Bernoulli, what happens? Bernoulli takes values p x, let's say px. Here p x is equal to x. Here it is p if x is equal to 1, and if x is equal to 0, it takes probability 1 minus p, right? This is the PMF of Bernoulli distribution. So x less than -1, it is always 0, right?
Yes, sir.
And what is f of 0.5? If you go through the definition, it is same as x less than or equal to 0.5, right?
Yes, sir. Yeah,
So
CDF will be that.
So what will be the value of this?
1 minus
X.
p.
Yeah, it is exactly px is equal to 0. Otherwise, probability is 0. Only it is defined only at 0. So it will be what?
1 minus p, sir.
1 minus p, right? So if I define what is f of 0,
That again will be P of x less than or equal to 0.
Yeah.
Zero.
So again, it is same as Px equal to 0. So it is 1 minus P, right? And if I define it f of 1, then it is same as x less than or equal to 1, right? So it will be now x equal to 0 plus x equal to 1, right?
So it will be 1 basically.
Yeah, it will be 1. So any point greater than 1, any point greater than 1, let's say 5 or something, any point greater than 1, it means that x less than or equal to 5. So it is always the sum of these two, right? So it will always be 1. So if you look at the PMF here, if you generalize these things, if x is less than or x is less than 0, then the f takes value 0, right? And if x is greater than 1 or are equal to 1, the probability is that f takes value is 1, right? But look at, if x is in between 0 to 1, if x is 0 to 1, then the probabilities become, then the function's values of f become 1 minus p, right? So this is how you define the CDF of a discrete random variable. Now look at, there is the gap, jump between these points. At 0, at 1, there are gap. If you draw this picture, if you draw the picture of CDF f and with respect to x, so if x is less than or equal to 0, the function's value becomes 0. But at 0 to 1, it becomes 1 minus p. So at 1, let's say here, somewhere here, it is 1 minus p. So up to 1, it becomes 1 minus p. But at 1, it becomes 1 again. At 1, it becomes 1, right? And this is excluding, this is including. So this becomes 1. So this is here 1. This is 0, and this is 1 minus p. So look at the curve here. Here it is a jump of 1 minus p, right? And here again at the 1 jump of p, right? So in the case of discrete random variable, CDF is always a CDF is always a CDF is always a step function. Step functions means that gap with that jump at some points. Here it is jump and 1, here 0 and 1. So where in the graph, if you see the jump, then the probability at that point will be inside the range of x, and the jump, the amount of jump will be the probability at that point. So if I say the probability that x equal to 0, so look at the jump at 0. So here it is 0, the jump is 1 minus p. So probability that x will take value 0 will be 1 minus p. If I look at the probability that x equal to 1, so here look at the jump amount of jump is this distance is p. So probability that x will take value 1 is p. So this is how you define the CDF for a continuous random, discrete random variable. Okay, so so let me give you some example. Let's say some function here. Let's say here it is 0. Okay, this is minus 1, this is 0, this is 1, this is 2. Okay, let's say this is your p1. Okay, so let's say this is your p2. Here it is something goes like that, and it is excluding, here it is including, here it goes to something, let's say p3. I'm defining some random random variable. Okay, now at 2 it becomes 1. Now give me the range of x. This is some graph of a CDF of a x. Okay, this is f of x, and this is x. Okay, so this is the CDF of x. Now give me the range of x here.
-1, 0, 1, 2.
-1, 0, 1, 2. Okay, so look at where the points where the jump occurs. That will be the points inside the range of x. Okay, so here jump occurs at -1, 0, 1, and 2. So these are your points inside the range of x. Now give me the probabilities of these things. P x equal to -1 will be what?
P1.
P1. Okay, and what will be the probability at x equal to 0?
P2.
P2 minus P1.
It is P2 minus P1. the amount of jump. Okay, so look at here. Here jump is of amount P1.
Okay. Okay.
Right?
Yeah. Yes, sir.
Here it is the jump will be P2 minus P1. Okay, so what will be the probability that x is equal to 1? It is P minus P2 minus P1, right? This distance P3 and this distance is P1 plus P2. So the jump will be of P3 minus P2 minus P1, right? And P x is equal to 2 again. This will be your 1 minus P1 minus P2 minus P3, right?
Sir, why do we have to do x is equal to 1 as P3 minus P2 minus P1? Why can't we only do P3 minus P2? Because P2 accommodates to all of that sum, right?
Oh, sorry. Yeah, exactly. So the P2 is this distance. Yeah, exactly. So P2, so this will be your P3 minus P2. Okay, and again in this case, this will be not P1 minus, so this will be your 1 minus P3, right? Because the P2 is the entire distance from here to here, right? So it will be your P3 minus P2, not P1. So this is how from a continuous random CDF of continuous random variable, you can define the PMF of that random variable, right? Just looking at the curve of that CDF curve. Now notice something in this CDF curve always. CDF curve is always a non-decreasing, right? It always increase. Because you look at it, just count the probability that x is less than or equal to x. So it is always the sum of probabilities. If you go higher points, then it may add some probabilities. It will never decrease, right? The values of that CDF at that point will never decrease. It will always increase or will be the same. So it is non-decreasing. CDF of a curve is always non-decreasing, right? Is it continuous always? Continuous?
No.
It need not to be continuous. Just look at this example. Here it is not continuous. Here jump occurs, right? So CDF need not to be continuous. Okay, it can be continuous. It need not to be continuous. Okay, and the maximum value of CDF, maximum value of f of x is always 1, right?
Yes.
And it occurs at the last point of that CDF, that range, right? Yeah, it becomes 1 at last point. So you can see that f of x tends to 1 when x tends to infinity, and the minimum values of f of x is
0.
0. So you can say that f of x tends to 0 when x tends to minus infinity. So these are the some properties of a CDF function. CDF is always non-decreasing.
Sir, so the CDF can be constant?
Yes, CDF can be
Also.
constant. CDF can be constant as well. Like if we say that x takes values 1 with probability only takes one value, then it in this case what will be x equal to 1? Then it is 1. So that constant, this CDF will be your
Okay.
no, not a constant function. Here it will be 1 and 0 below 0, right? Something like that. At 1. So this is your 1. Somewhere here it is 0. Okay. So it will look something like that. So these are your properties of a CDF. CDF we define. First is non-decreasing. Second, f of x tends to 1 when x tends to infinity. Second, f of x tends to 0 when x tends to minus infinity. Okay, so and one more thing, CDF is always continuous from the right side. From this side, if you look at the right side, means that from the right side, it always be continuous. Need not to be continuous from the left side, but always from the right side, it is always continuous random variable. So this is the properties of a continuous CDF function. Now,
So what do you mean by that left side, right side, continuous?
left side, right side continuous means, do you know the concept of limit?
Yeah, yes,
Limit of
sir.
a function. So if how do you define a continuity at a point x?
When the right side limit and the left side limit are equal.
When right side limit equal to left hand side limit and the values at that function,
Yeah.
right? Then
Yeah, yes,
you
sir.
say that the function is continuous at that point x, right?
Sir.
But the meaning of right side continuity means the function's value is equal to right hand side limit.
Yes,
Okay.
sir.
Then I say that this is continuous from the right side.
Okay.
So in this case, look at this graph. The value at 1 is something 1, and if you look at it is approaching to 1 when we approach from the right side, right?
Okay, okay, sir. Yeah.
So right hand limit is equal to function value at 1, right?
Okay.
So,
So will this always be like this only, sir? I mean,
yeah,
we always
CDF
consider it
will
like
always be right
be
side
like this.
continuous.
Okay.
Right side continuous.
Okay.
Look at
Fine,
the left side continuity here. It is f of 1 is 1, but f of 0 is approaching to what? 0, right? From the left side.
Yeah,
So it
yes,
is
sir.
not the left hand continuous, left side continuous. It is right side continuous only.
Okay, sir. Thank you.
Now come to the continuous random variable. So in this case, discrete random variable, always remember the CDF function is always a step function. Okay. But in the continuous case, if the CDF of a function, if a CDF of a random variable x is a continuous function, then you say that x is all a continuous random variable. So this is the technical definition of defining the continuous random variable and the discrete random variable. And the definition is, if the CDF of a random variable x is a continuous function, then that x is called a continuous random variable. Okay. This is the technical definition of defining the continuous random variable. Okay. Now the questions comes, if you have seen some questions in the assignments, like have you gone through the questions of assignments? Okay, look at the second question. This question, second question. Can you see the question? Hello.
Yes, sir. Yes.
Okay, so look at the second question. Now the CDF of a random variable x is given to you. Okay, this is the CDF. How the CDF is defined in this way. Now you need to find the range of x here. So how you will find the range of x? What will the range of x here?
So 0, 1, 4, 8.
Yeah, why 0, 1, 4, 8?
Because the CDF has been defined between these ranges. Where, I mean, the step function happens between these ranges. The probability
the jump occurs at these points. The jump occurs at these points. So it looks, if you draw the graph, it looks something like that. X is given at, let me check. At 0, it takes value 0. At 1, it takes the jump of 0.29, right? Then it takes the jump of something 68 minus 0.29. Then again at the 4, it takes jump of 0.20. And at 8, it takes the jump of 1 minus 0.88, that is 0.12. So something, the graph of it looks something like that. From 0, below 0, it is 0. And at 1, at 0, it becomes something 0.29, right? And somewhere here it is 1. At 1, it again takes the jump and it becomes 0.68, and it becomes 0.68, and at 2 it becomes something 0.88. At 2 or 4, it becomes 4. At 4, okay. So at 4 it becomes 0.88, and at 8 it becomes 1. So if you draw that curve, it will look something like that. Now look at the points where jump occurs. Jump occurs at 0, at 1, at 4, and at 8. So the range of x will be what? 0, 1, 4, and 8. This will be the points inside the range of x. Okay. So notice here it is given in the question, it is a CDF of a discrete random variable, right? If it is not given, can you distinguish this is the discrete random variable or a continuous random variable? Let's say no information is given to you. It is saying that it is the CDF of a random variable x. Now you need to distinguish whether this x is a continuous random variable or discrete random variable. So how you will distinguish between whether this is of discrete random variable or a continuous random variable?
Or if it was continuous, then its graph also would be continuous.
Yeah, the only difference between these, the graph of a CDF of a continuous random variable is always continuous curve, while the curve or say graph of discrete CDF of a discrete random variable is always a step function. So now look at this function f of x that takes this continuous function, right? Because if you look at the 0, it is 0 at 0. From the right side it becomes 0.29. So definitely it is not a continuous random variable. It is a whether discrete random. It is the curve of CDF of a discrete random variable, right? Now what is the p x equal to 4 here? P x equal to 4. Just look at the curve now. X equal to 4 they here. So I just told if you need to find the probability at that point, just calculate the jump at that point. 4, it is how much jump here? This is 0.88, this is 0.68.
0.18.
0.18.
Oh, 68.
Right? 0.88 minus 0.68. So the jump at the 4 is of 0.20. So the answer will be 0.20. Okay. Yeah, answer is 0.20. Okay, so this is the way to find finding probabilities using the CDF function. Okay. Now look, the same thing we have discussed here again. Yeah, you can solve this type of questions here now. Now just go to our main concept of the continuous random variable. Now I told you if the CDF of a random variable x is a continuous curve, then the x is a continuous random variable. Okay. And there is another type of random variable which is called mixed random variable, which is not a continuous nor a continuous nor discrete, something like that. Something, let's say this something here 0 it becomes here, and here at 0 takes jump and goes up to something like that and becomes 1 here. So this curve, if you look at this f of x, this curve f of x, and this x is not a continuous random variable nor a discrete random variable because it is a jump here, right? So and here it is continuous function. So this is called mixed random variable. Now what's next? Yeah, what the CDF for a continuous random variable is defined in the same way. Okay, so my point is only that if you need to distinguish between these things. Okay, now tell me in this question, second question, can you see the question?
Yes, sir.
So now you need to distinguish whether a given curve is a valid commutative function or not. So look at the first option. Is it a valid commutative distribution function? Always remember the properties. First property is what? It is always non-decreasing. Right. Second property, it always tends to 1 when x tends to infinity, and third property is always tends to 0 when x tends to minus infinity. Okay, and the next one is it is always continuous from the right side. Now check all these 4 properties. First, it is non-decreasing. Yeah, first is it is non-decreasing, right? and at infinity it tends to 1. Look at at 1 it becomes 1, and at 0 it becomes 0. That is at less than 0 it is always 0. So this function is a valid cumulative distribution function, right? Now tell me this function,
No, sir.
why not?
Except that black dot would be on right.
Yeah,
But
you
it is
can
not
say
an
that.
increasing function.
Yeah, it is again a first is it is non-decreasing function. Here it is decreases, right? At look at somewhere in between 0 to point at 0.1, it is 0.6 and then decreases up to 0.3. So it is non-decreasing function. Or you can say again that is not out continuous. Again, it is not following the second properties, the last properties as well. So it is not the valid CDF. Now look at this function. All the properties are satisfied, right? It is continuous, it is non-decreasing, it is tending to 1 when x tends to infinity, and it is tending to 0 when x tends to 0, x tends to minus infinity. So it is again a valid CDF function. Now look at this function. Is it valid CDF or not?
No, sir.
Why not?
It's decreasing.
Yeah, it is decreasing function, right? So it is not a valid. So answer should be okay. Only these two are the valid CDF, and remaining are not. Okay. So this is how you distinguish whether you find out whether a given function is valid CDF or not. Okay. Only look at the given 4 properties whether the function satisfies or not. Okay. Now look at one more questions regarding that. Now here, second question. Now here you need to find whether this is a CDF of a continuous random variable or not. So how you will define a CDF of a continuous random variable? What are the properties you will look for? What are the properties you will look for whether this is a valid CDF of a continuous random variable or not? Hello.
Sir, when I substitute x equal to 1 in the equation, like 1 by 3.5x plus 1 by 1.4, I should get a value tending towards 0.7. And then, I mean, if I check that way, it will show that it is continuous.
Yeah, so what I'm looking for, I'm just checking whether the function is continuous or not at every point, right?
Yes, sir.
Because I just told CDF of a continuous random variable is always a continuous curve.
Is there any other method to do that, sir, or this is the method to do?
Yes, so you need to check all the properties. First thing, whether it is all non-decreasing or not. So it is given in the question, all the functions are non-decreasing functions. Second is always tends to 1 when x tends to infinity, and x tends to 0 when f of x tends to 0 when x tends to minus infinity. These are the 3 properties. And the third one, because I am to check whether it is of continuous or not, so I need to check whether the function is a continuous at every point or not. Okay, so every point I will just look for where the function definition changes. Otherwise it will be continuous function, right? At every point within -2 to 1, it is the algebraic function, or algebraic functions are always continuous, something like that, right? So you need to check the continuity at every point where the function's definition changes. Okay, all other properties you need to check. Now look at the first option. In the first option, if you look at the first option here, it is tending to 0 when x tends to minus infinity, and it is tending to 1 when x tends to infinity. Okay, this property is satisfied. Non-decreasing is always given in for all the options. Now look at the continuity thing. You need to check the continuity at -2, 1, 2, and 3, because that's the where the function definition changes. Okay, look at -2. From the left hand side, it is tending to 0, and it is from the right side. It is what will be the value from the right side? This will be your -1 plus 1.4. That is 0.4 by 3. That is not equal, right? So it is not continuous at -2. So this is not a continuous function. So this first option is not correct. Now look at the second option. Is it continuous? It is CDF of a continuous or not? So how you will check? How you will check?
This one is continuous.
So how did you check that?
The left hand limit, right hand limit, and value in the.
Yeah, you'll just check the continuity because the all other properties are satisfied. Now look at the fourth option. Fourth option is a CDF of a continuous or not?
No, sir, because at 0 it jumps.
At 0 it jumps.
Yes, it becomes 1/4 plus 1/2.
1/4 plus 1/2. At 0, why it is jump at 0?
You are asking the third one or the fourth one, sir?
Fourth one.
Okay, I probably am answering the third one. Sorry, sir.
Yeah, third one is not continuous because there is jump at 0.
Yeah.
I'm asking for the fourth option.
Continuous.
Why? Is it continuous function or not? You will check the continuity at 0 only, right? At all other points, it is continuous.
Yes,
Yes.
sir. It is not continuous because it's 0 and 1/2.
At 0, it is what?
At 0, I mean the left hand limit is 0 and the right hand limit is 1/2.
Right hand limit is again 0.
How is it 0, sir? It is 1/2.
Zero.
1 minus.
E power 0 is 0 now.
Yeah, but then there is 1/2 into 1, right?
E raised to power 0 is 1.
1.
Yeah, right. Okay. Yeah. Sorry, sir. I confused. Yeah.
So it is a continuous function.
Yes, sir.
Right?
Yes, sir.
So it is a CDF of a continuous.
Yes, sir.
Yes.
It is not. It is not. It is not satisfying one of the properties. Which property it is not satisfying?
Oh,
It should
So
be
it's-
1, 0 to 1.
Yeah, the max that it should function's value should tends to 1 when x tends to infinity. But in this case, when x tends to infinity, what is the value here? When x tends to infinity, what is the function value?
0, sir. So it won't be.
X tends to infinity, function value is
1/2.
1/2.
minus 1/2 minus
Okay,
2
look at the
1/2
function. Function
minus
is your 1/2 into 1 minus raised to power minus x, right? I'm saying when x tends to infinity, what is the function value?
It is 1/2, sir.
Yeah, 1/2.
Yeah.
So it is
1/2.
not tending to 1, right?
Yes, sir.
Yeah.
So this is not a CDF. It is not a CDF. Okay. So always check all the properties, not only single property. Okay. This function. Okay, this is not a CDF of a continuous. Just solve these questions. We will move ahead now. Okay. So yeah, this is all about the CDF of a continuous random variable. Now let's move to the PDF. So how do you define the PDF?
For continuous.
Yeah, PDF is already defined for continuous random variable, not for the discrete random.
Yeah. Sorry. So
This
you
is a probability density function.
can differentiate the CDF.
So this is how you define the PDF. Have you seen the lectures? No, right?
Not yet, sir.
So before defining a PDF, just define the density function in general. A density function, just look at the 7 point here. A density function is a function from real line to real line if it satisfies given three properties. The properties are it is always non-negative function. The second property is the area under that curve is always one. The third property it is piecewise continuous. So what I mean by piecewise continuous is the functions something looks like right something like that. It is continuous and somewhere jumps at only some points. So it is piecewise continuous means that it is continuous in given intervals. It is continuous here, it is continuous here, it is continuous here. So some functions like that is called piecewise continuous functions. So if function f is in general I'm talking about if function f is called a density function. If it is non-negative, it takes values non-negative values, and second property is the area under curve, that is f of x dx, area under the curve is always one. The third property is it is piecewise continuous. So if a given function satisfies these properties, then that function is called density function. Okay, so just look at one example here. It will be clear. Okay, so there is no such example in the activity questions.
So activity 1 will have, sir.
Activity 1.
Yes, sir. Valid.
Activity 4.2, you mean?
Yes, yes. So they'll have valid, which is valid. All these questions will be here.
No, it's not here.
There'll be one question, sir, with yes, no. Or probably the next activity. One of these activities have.
It's a valid CDF.
Yes, sir. Probably this one.
This is the CDF of a continuous random variable. I think it's not here.
No, sir. One of the activities had a question. Let me check.
This one, right? Third question. Look at the third question
Yes,
here.
correct.
Yeah, that third question has given a function f of x is defined such way for 4 by 15 x cube when x takes value -1 to 2 and 0 otherwise. Now it is asking whether function f a valid density function or not. So you will check the three properties, right? First is non-negative. The second is the second property is area under the curve is always -1. Sorry, area is always positive 1, and the third one is always piecewise continuous. So it is continuous, no doubt, right? The first property this satisfies. The first property is always takes non-negative values. But at -1, look at -1, it is minus, right? So it dissatisfies the first property. So it is not a valid CDF. It is not a valid density function. So whenever you're checking the density, whether a given function it is valid CDF on valid density function or not, you need to verify the all three properties. So in this case, it is not satisfying the first property. That's why this is not a valid density function. Okay. Now look at the fourth question. Fourth questions asking for which of the combination of A, B, and C values, which combination of A, B, and C makes f a valid density function. Now how you will find these combinations? Look at first thing is that it should be always functions values should always be positive, right? So look at the first option. First is taking values a -2 to 1, right? Just give me a minute. Yeah, so look at this question. So look at the first option. First option, x when
Sir, your
x.
screen is not visible.
Okay. Now look at the first option. What goes wrong with the first option? If x takes value -1 to 1, the function's value will become positive, negative, can become negative, right? Because it is defined as cx cube and c is 4 by 15. So in this case, what will happen? Let's say x is equal to -1. So at x is equal to -1, this will be your -4 by 15. So it is non-negative at that point, right? So first option is not the valid combination of A, B, C. Now look at the second option. Second, A and B. A is 1, B is 2. So it is x takes value 1 to 2. So in 1 to 2, it is defined as 4 by 15 x cube. So it is always positive, right? And the third property, it is always piecewise continuous. Here it is satisfying because it is a continuous function. Now look at the second properties. Now your function is defined as 1 by 15 x cube when x takes value 1 to 2. Right? C is 4 by 15, 1 to 2. Now you need to check the second property. Second property says that your area under the curve inside the range is always 1. So check this property. It is 4 by 15, 1 to 2 x cube dx. So this will be your 1 by 15. This power 4 by 2. This will become 15 by 15. So it is 1. So it is satisfying second properties also. So this will become your valid density function. Okay, so for this combination, this become a valid density function. First is not true. Third one is not true because C comes out 4 by 15. And for the fourth option, you need to check. Okay, check in the same manner. You will
Both
it
is
will
correct,
again.
sir.
Okay, so for these combinations of A, B, and C, you will find F is a valid density function. Okay, now let's come to the PDF of a random variable x. So how do you define the PDF of a random variable x?
If f dash of the differentiation of the CDFs.
Yeah. So if f is a CDF of x, then the if any function f satisfies something like that, f of x equal to -infinity to x, f of x dx, then this f small f is called PDF of x. Okay, so this is the technical definition, but it doesn't give the much interpretation from here. So the PDF gives you the density at a particular point. Let's say my some function f of PDF of some random variable x is something like that. Okay, just assume this is the PDF of a random variable x. Okay, so it means that if I need to find the probability, this is your somewhere here 0 and somewhere -infinity. Let's say this is somewhere point A, somewhere B. If I need to find the probability that P lying between interval A to B, then I just need to integrate the I need to find the area under the PDF curve inside this interval. Okay, so what I need to do, I need to find the integral value, because integral inside the interval of that function give the area under that curve. Okay, so this will give you the probability within the interval A to B. Just integrate the PDF function in the range A to B. Okay, so what will be P x is equal to x now? So x is equal to x, you can think as P x is lying between x to x, right? Just a single point. So what will be this? This is your x to x, f of x dx. So interval is same, right? So this is 0. So probability at each point, at every point for a continuous random variable is always 0. Okay. So always remember this point. Now, what I mean by f of x exactly? In the PMF, we just in the discrete case we define PMF and say f of x means what? It is the probability that x takes value x, right? This is how you define PMF. So what exactly means by f of x for a discrete and PDF? F of x, what it gives you. Let's say in this case, in this example, this is your PDF of a random variable x, and somewhere here it is x. And what is the mean of that f of x? So f of x will be something like that, right? And if x is lying somewhere here, so f of x will be this value, right? This value. So what it means? What it gives? F of x value gives you. Does it give the probability at that point? The question is clear, right? What the question means?
So, but the probability can be defined with CDF itself. No?
Sorry.
The probability can at a single point is 0 for a continuous function. Then why are we looking at the probability at a single point?
Yeah, that's what I'm asking. What does f of x means?
In continuous or discrete? Sir?
That PDF. This is the PDF of a random variable x. So obviously x is a continuous random variable. What my question is, what is f of x here?
Probability over the range, sir.
Probability. I'm just asking values at a x. In let's say this is
It
your
will be 0,
PDF.
sir.
This is given to you f of x. So this value is your f of x, right? This is x, then this is f of x. So what does it give you? F of x is, let's say here it is
Probability
2.
at a
So what it means?
probability at a point.
Probability
X.
at that point, is it?
That should be 0, but I am not sure why you are getting
So
to.
yeah. For in the continuous case, it is always 0. So what it means? What it gives you?
This means that you can't find the probability for single point. It can only be through a range.
Yeah, probabilities is always you need to find at a point always 0. So if you find that within the interval, you just find let's say if I say a to b, is what in the form of, if I write in the expressions of CDF, it will be f of b minus f of a, right?
Yes, sir.
Yeah, here inequality, if you include or not, doesn't matter a lot, because x all at a particular point it is always 0, so you can include or exclude equality here, right? It won't affect in the case of continuous random variable. And this thing in the form of CDF, it will be f of x dx from interval a to b, right?
Yes, sir.
Okay, so my question is, if I write f of 2 taking value 2, so what it means? Okay, so exactly this is not the probability, first thing, right? Don't
Yes,
take it as the probabilities. First thing is that it is the density around that point, density of probability.
Okay, sir. So it is more on where
At
the
that
probability lies. Okay.
It means that how probable that point to occur, right? So it means if somewhere here, if you look at this graph, the here the density values of f of x is the highest, right? So
Okay,
it means
correct.
that the probability that these values will occur is more likely to occur. This point is more likely to occur. The x takes value near this point is more likely. Okay, so it is
Okay,
like how dense the probability around that point. Okay, if you look at the one question here, yeah, look at this graph. This is the PDF of a random variable x. PDF of a random variable x is given in this graph. Okay, now it is asked. Now look at the third option and fourth option. Read the third option. Third option says that probability that x will take value 0.95 is higher than probability that it will take value 0.2. Is it true or wrong? 0.92 is somewhere like here, and 0.2 is here, right? So this option is true or wrong?
Third one is false, sir, because it is giving exact values.
Yeah, because probability that x takes value 0.95 is always
It's
0,
zero.
right? And probability that
Correct.
it will take value 0.2 is always 0. So third option is wrong. Look at the fourth option. Fourth says that probability that x will take value close to 0.95. Now we are talking about the around 0.95 and around 0.2. Now look at the PDF curve. Here values of PDF at 0.92 is greater than 0.2, right?
Correct, sir.
So values x will take close to 0.95 is more likely, right?
Yes, sir.
So
Correct.
probability that x will take close to 0.95 is more likely that it will take near to 0.2. Okay, clear? So any doubts in this?
No, sir.
So my point only is that don't take it as the probabilities. This is not the probabilities. This is the dense how probabilities are dense around that point. Okay. Now this is how you define the PDF of a random variable. So for a continuous random variable, you need to find the probability within interval. How you will find it is just f of x dx inside that interval. Okay. So let's say given a CDF function f of x. So it is what? It is px less than or equal to x, right? So you can write it as p minus infinity to x to x. So this is what? This is your minus infinity to x f of x dx, right? So you can say f of x is what? Minus infinity to x f of x dx. So for finding the probabilities inside the interval, what you need to do, where if the CDF function is given, just differentiate the upper point minus lower point, and if the PDF is given to you, then just integrate the PDF curve inside that interval a to b, right? If this is a to b, then just integrate that PDF curve inside that interval a to b. Okay, so these are two methods to finding the probabilities inside the interval if CDF is given and if the PDF is given to you. Now this is what now look at some examples for the continuous random variable. First comes as the uniform random variable, uniform continuous random variable. So uniform, the same thing, the each and every point is equally likely to occur. So if I say x is uniform within interval 0 to 1, or say uniform into the interval a to b, means that each point inside the interval a to b is equally likely to occur. Okay, so what will be the density? So first thing is it should be clear that the curve inside the range of x, f of x, d of x, inside all the range of x, let's say f d of x, it's always one, right? Because this is what probabilities, sum of probability, or say probabilities for inside the entire range of x, that is always one. So this should be always one, right? So what I mean here, what will be the uniform a to b? Each and every point inside this interval is equally likely to occur. So f of x will be what? This is just it is something like the PDF will be same, right? So PDF will be what? This here a, this is here b. So each and every point is equally likely to occur. So the PDF will be the constant curve, right? So PDF will be the constant curve. Now I'm to find the PDF this point. So what will be this point? I need the property that the area under this curve will always be 1, right? So this length is what? This length is b minus a. And to make the area 1, what will be this height? What is the area of this area? What is the area of this region? This will be your this length L and this height h, right? L into h. So this should be 1. So L is your b minus a. Into height you need to find. This is 1. So what will be your height? 1 upon b minus a, right? So what is the PDF? PDF of a random variable of a uniform AB will be 1 upon b minus a when x lie between a to b, and otherwise it is what? Otherwise it is always 0, right? So this is your PDF of a uniform random variable. Okay, so what will be the CDF of f of x? CDF of x how you will find the CDF from the PDF?
So upper limit minus lower limit by b minus a.
Yeah, the integration of 1 upon b minus a f of x dx from the upper limit a to x, right? I'm just finding up to x only. Actually, what I'm doing, I'm finding probability that x will be less than or equal to x. It means that probability that a, because the lower limit is x, a to x. So what will be this? This is just the integration 1 upon b minus a dx from a to x. So what will be this? This is 1 upon b
X minus a by b minus a.
x minus a, right? So this is your CDF. CDF will be defined as x minus a, e minus a upon b minus a when x is a to b, and when x is greater than or equal to b, it becomes 1, and 0 when x is less than or equal to a, right?
Sir, can you please explain what is support?
Yeah, what is support? So support of x is defined as the all those points within on the real lines, all those points with the real time where f of x is 0. Just give me a minute, okay? Yes, so support. How do you define the support? Support of a random variable x is the set of all real numbers where f of x is 0. Okay, so let's say my x is uniform AB. So what will be the support of x?
A to B.
So support is all those points where f of x is not 0. Sorry, sir. It's non-zero. Or say f of x is strictly greater than 0 because f of x never takes negative value, right? It never takes negative value. So all those points where it is not 0. Okay, so it is strictly 0 or strictly greater than 0. You need to find all those points, and this will be your support. So in this case of uniform AB, what will be the support?
A to B.
A to b, sir.
And A is including or excluding?
If a is, it has value, right? So a is included.
So B is included. What is about A?
A also has probability, sir. So
No, it's not the probabilities. Okay, probability is always 0 at a point. I need to find what is f of A, whether it is 0 or strictly greater than 0.
it's strictly greater than 0, so it's not
F
zero.
of A. What is f of A in this case?
Sir, in this case, we don't know
In
that.
this case, we don't. It's not included, sir, because you've given 0 for less than or equal
A,
to.
f of A is 1 upon B minus A. It is always 1 upon B minus A, right?
Yes, sir.
Inside this, I said x is a uniform.
Yes, sir.
AB. So support of x will be A to B. Okay. Now let's say I think some 1% is given on the activity on the support.
Yes, sir.
Now
Yes,
look at this PDF curve. This PDF is defined something kx between x takes value 0 to 1, and k is a constant. Now what is the support of x? You need to find all those points of x where f of x is non-zero. Now look at definitely from below 0 it is 0, and after 1 it is 0, right? So inside the interval 0 1, it will take value kx, right? So it is non-zero into 0 to 1, but 0 is including or excluding?
0 will be excluding, sir.
0 will exclude because at 0 the value of f of 0 will be 0, right? So
Yes.
I need to find all those points where it is non-zero. So answer will be 0 to 1. And at 1,
Sir, but the answer is different. Check once.
So it
Okay,
is
so
less than 1. That's why
Yes,
it's not
sir.
less than equal to.
It will be a first option.
yeah, it is function at 1.
Both
At 1
endpoints
it is
exclude
defined
also.
0. At 1 it is defined 0. Look at the function definition here.
Okay.
Is it clear now?
Yeah. Yes, sir. Yes.
Otherwise it is defined 0 and 1 is not included here. That means at 1 it is 0. So the answer will be A. Okay.
Sir, we have a question.
Yes.
In lecture 4.6, Andrew sir spoke about exponential distribution, in which he talked about a specific kind of property, as in P of x s plus t given.
Yeah, we will come to that. Just yeah, we are our next distribution the main, is exponential, right? We will come to that. Okay, so
Okay, sir.
it is clear about the uniform. Any doubts in the uniform distribution? No. Okay. So the exponential is defined as where the f of x is lambda e raised to power minus lambda x, and x is always greater than or equal to 0 and 0 otherwise. Okay, this is the PDF of a exponential distribution, and the CDF is defined as CDF. How you will find this integrate, right? Lambda e raised to power minus lambda x dx from minus infinity to x, and minus infinity you need to worry about. You just take from 0 to
Sir,
x. So
it's greater than 0. X greater than 0.
x is strictly greater than 0, is it?
Yes, sir. It's given in the PDFs, the formula PDF.
No, you can include at 0. It won't affect it. You can include 0.
Okay, sir.
So actually in the if you look at the examples of exponential, it is the time or say arrival time, the time interval between two events. Okay, so this kind of scenarios are modeled using exponential distribution. Let's say if I'm saying that time between two buses arriving at a bus stop. Okay, so here this kind of distributions follows the exponential distributions, or say any Poisson distribution, the time interval between two events. So give me some examples for Poisson distributions. Let's say number of customers, right? Number of customers arriving in 1 hour period, right? So to the time between two customers. Okay, the time interval between two customers arrives. That time interval will be your exponential distributions. Or give me any other examples for Poissons. Or say that accidents, right? Accidents occurs at the highway. So the time interval between two consecutive accidents will be your what? Exponential distributions. Okay. And what will be the mean of exponential? It is 1 by lambda. That is the on an average there 1 by lambda will be your time interval between two events. Okay, so that scenarios are modeled using exponential distribution. So you can include a 0 or not include, doesn't matter, because what will be the time interval? It can be start from 0 to infinity, right? Time can start from 0 to infinity. So you can include, exclude, doesn't much affect, because the probability is always 0. So including, excluding doesn't affect much. Okay. Yeah, but if it is given greater than 0, then it is good to accept this, because the support, you will always talk about support of x, then you always take from 0 to infinity. So you can exclude that equality here. Okay. Now, so what is the PDF of a exponential distribution? It is lambda e raised to power minus lambda x, when x is greater than 0 and 0 otherwise. Okay, and what is the CDF of that? If you just integrate this from the 0 to x, this will come as f of x. Let's say this will come 1
minus e
minus
power minus.
lambda x. Okay, when x is okay, so when x it is 0 when x is less than or equal to 0, and if x is 0 to infinity, this is how you define the CDF of exponential distributions. Okay, so
So we had a question.
yes.
So in this function only, they gave a specific example in which they had a condition, that is x is greater than s plus t, given that x is greater than s. So this
Yeah.
probability, sir mentioned, it will be e power minus t. But as of we calculate, it is coming out to be e power minus lambda t. So which is correct? In the slides, it is given as
Okay,
e power
so
minus t.
this property is called memoryless properties.
Yes, sir.
So memoryless properties says that it forgets everything which happens already. Like what is the probability that x will be greater than t plus s, given that x is greater than t. It is same as probability that x is greater than s. So this kind of thing is called probability memoryless properties. You must have seen in the case of geometric also, right?
Yes, sir. But
So
when we calculate this, sir mentioned it is e power minus t. But when we calculated, it is coming out to be e power minus lambda t, or in our case, it was 2t. But which is the right format, sir?
no, it will come out as e raised to power minus st.
Yes. Here, yes,
Sx,
you
sorry,
mean.
Sx. X greater than, sorry, e raised to power minus lambda s.
So this
Yeah.
lambda s is correct. So,
Yeah, lambda s is correct.
okay, so
This is called
slides are wrong then.
Yeah, so maybe in the slides it is given wrong. So it is called memoryless properties. So what's happening? We are finding the probability that x will take more than t plus s, given that x takes value t. So it is same as x will take s. So it has already forgotten what has already happened, that x greater than t has already occurred. So it is forget all about this. It has started from the initial that it will take, what is the probability that x will take more than s, right? So this kind of property is called memoryless properties.
Okay, sir.
Okay, so one way to think is like that. Let's say you are waiting time. Okay, this is very good example for understanding the exponential distribution. Let's say you are waiting at a bus stop. Okay, and the arrival time between two buses follows exponential with the parameter 1/4. Let's say 1/4. It means that on an average it takes 4 minutes to arrive a bus. Okay, after 1 minute passes. So 1 by lambda is mean. Okay, 1 by lambda is the mean for the exponential. So it takes on an average 4 minutes to arrive a bus. Now now you know you are interested in that what is the waiting time for that. So you are interested that what is the probability that you will wait more than 5 minutes. Okay, and if you already know that it already have passed more than 3 minutes, then what is this? This is the same as probability that what is the probability that you will wait for more than 2 minutes. That it is already forgotten what has already occurred. This kind of properties is called memoryless properties. Okay.
Okay, sir.
Okay, so this is all about the exponential distributions. So next is normal distribution. This is distribution which is occurred most frequently in the statistics, and you will see from week 7 onwards how the one random variable, also sequence of random variables, sum of random variables can be approximated using normal distribution. So always remember about PDF of a normal distributions. The PDF of a normal distribution is f of x is normal distribution has two parameter mu and sigma square. It is actually the mean, expected value, and this is the variance. Okay, so this has two parameter mu and sigma square. So PDF is defined as f of x is defined as and the range of or say support of x is what? Minus infinity to infinity. Okay, so f of x is defined as 1 upon root over 2 pi sigma square e raised to power minus x minus mu to whole square upon 2 sigma square. Okay, so this is your PDF of a normal distribution, and CDF has no closed form. Okay, so for finding this is called normal mu sigma square, and PDF of this curve is always symmetric around mu. Okay, so this is mu, so this is symmetric around this mu. Okay, so mu is the means, and somewhere sigma square is the variance. Okay, so this symmetric properties is very handy properties, because if look at okay, so first coming to the probabilities of inside the interval, just let me define the standard normal distribution. The standard normal distribution is the normal distribution with the mean 0 and the variance 1. Okay, so it means that the curve of the normal distributions look like this. So it will be symmetric around 0, right? So it means that symmetric means symmetric properties say that this now this is the PDF of a normal distribution. So area will be area inside this curve also always 1, right? That is f of x dx minus 1 minus infinity to infinity is always 1. So if you look at the symmetric property, it means that this area is same as this area, right? So it means that what is the probability that x is greater than 0? It means that I need to find the area, this area, right? I'm interested in this area, this half area. What will be this half area?
1/2.
1/2, right? What will be x less than 0 or less than or equal to 0? Again, this is 1/2. Just using the symmetric property, I am able to say that this probability is 1/2. In the case of normal mu sigma square, what is p x less than or equal to mu? Always keep this picture in mind. This will be something like that. It will be symmetric around mu. Okay, so this area is same as this area. Okay, so this area will be 0.5 and this area will be 0.5. So x is less than or equal to 0, mu will be this area. This is same as 0.5, and x is greater than or equal to mu is the same as this area. This will be again 0.5, right? Now look at okay, so one thing is that all x, let's say x follows normal mu sigma square, then x minus mu upon sigma square follows normal 0 1. Okay, so every time you can convert normal mu sigma square to normal 0 1 using this. And why this is useful? Because you need to find the probability that, let's say, x follows normal mu sigma square. I need to find probability that x will take between values a to b. So what is this? This is just the this is somewhere mu. Okay, let's say it's a b here, a here. So I need to find this area. So what I will do, I will convert into the standard normal distributions. And how I will do that? I know that x follows normal mu sigma square, then x minus mu upon sigma square will follow normal 0 1. Okay, so what I will do, I will just subtract by the mu a minus mu. So this will be your x minus mu by b minus mu. Okay, and what will be next I will do, I will divide it by the sigma square. So this will be x minus mu upon sigma square less than b minus mu upon sigma square. So what is this? This is normal 0 1, right? So this is your normal 0 1. So look
Sir,
how
sir,
I was, yes.
Sir, I had a doubt. For standardization, you divide by standard deviation, right?
Oh, okay. This is sigma. Sorry. I made a mistake. So this is x minus mu by sigma, right? You just check expectation of what is the expectation of x minus mu upon sigma. This is 0, right? What is the variance of x minus mu upon sigma? This is 1 upon sigma square upon variance of sigma, right? So sigma square by sigma square. So this will be a 1. Sorry. This is not sigma square. This is 1. Sorry, sigma only. So this is sigma. This is sigma. This is sigma. This is sigma, not sigma square. Okay. So look, I was interested in finding these probabilities, and I have converted it into the normal 0, 1. Okay. So this is how you will proceed to finding any probabilities of a normal distributions. Okay, and this probabilities is given in the table format, or in the some packages are used to find this property, this values. Okay, this is very standard function, normal 0, 1. Okay, so always remember this curve and this, and this normal 0, 1 is generally denoted by capital Z. Okay, so always remember this curve. This is always symmetric around 0. Okay, and one thing, let's say, so I need to find this tail area. Okay, let's say this is your PDF of Z. Okay, so f of Z of this is, let's say, this is your minus A, and this is A. So what is f of Z of minus A? This area, right? Probability that Z is less than or equal to minus A, right? And look at this area. These two areas are same, right? So P of Z less than or equal to minus A is the same as P Z greater than or equal to A, right? Two tails. This area is same as this area, just because of symmetric nature. So this you can convert f of Z of minus A is what? This is just P Z less than or equal to minus A, or you can convert it into P Z greater than or equal to A. Just remember this picture, right? So this is what? This is 1 minus f of Z of A, right? Clear? Any doubt in this? Have you any doubts in this concept? So always remember this picture in your head. This will be very useful when we will go in the big 7, big 8, and big onward hypothesis testing and all. These things will be very handy. This needs some practice. It will be very, very easy, right? Now, I think we have done with the distributions. Only 3 distributions are mainly used. This is uniform, exponential, and the normal distribution. Now, one thing in the discrete random variable we have done, we have finded the PMF from a given PMF of x. We have finded the PMF of a function of x. Let's say pi of x square. We have find the PMF of y, right? Now, the same kind of thing we will do here, but in a different manner. We will we have been given the CDF of or the PDF of x. Let's say f of x is the PDF, or say f of x is the CDF of x. And now we need to find the PDF of f of x, function of x. That is, let's say by some function of x, I need to find the PDF and CDF of y. How you will find this PDF and CDF of y? Anyone? Anyone who has gone through the lectures, how you will find the PDF or CDF for a given function of x?
So we can use the formula.
Formula is always used only for given conditions. It should be monotonic
increasing or decreasing, yes, sir.
Monotonic function and differentiable function.
So we integrate, find the CDF, and then apply the y value.
So always follow some steps.
Sir, your screen is not visible.
Is it visible now?
Yes.
Yeah. So let's say I will give you one example, then it will be easy. So steps, always follow the steps. First step is find the support of y by some function of x. Okay, by some function of x. First step is your find support of y using that function definition. Second thing, just write the CDF of y. You need to find the CDF of y. and then you can convert the CDF of by into the PDF of by using differentiation. Okay, so just for a example, let's say your X is uniform 0 to 3. Okay, your y is X square. Now what I need to find the support of I need to find the PDF of y using this method. So what will be your support of y? X is defined into 0 to 3. So where y will be defined, y is defined as X square.
0 to 9, sir.
0 to 9, right? Now I need to find the CDF of y. CDF of y, what? Let's say f of y is CDF. So what is the definition of CDF? So y I am choosing inside the support of y. So, y is in any point inside the support of y. So f of y will be f of y is less than or equal to y, right?
Be on the reverse other side expression. So once we grow as an individual, we should also have.
Right. This is the definition of CDF, right? So what I know the CDF of x or PDF of x. So what I will do, I will convert this definition to the definition of x. Okay, so y is defined as x square is less than or equal to y, right? Y is defined as x square. Okay, so I will convert into the x. So it is same as x square less than or bar same as x is in between y to y, but x is always x is defined
The
into
root y, sir.
yeah, root y. So but x is defined into 0 to 3. So no matter I need not to worry about the minus quantity. So it is same as 0 to y. So what will be this? What is this probability?
2 times.
Root?
2 root y.
Yeah.
2 root y by 3.
Okay, just tell me if x follows 0 to 3, what is the probability that x is less than or equal to 2?
F of 2, sir.
Yeah,
Capital
F of 2.
F of 2.
What is f of 2?
In our case, it is uniform, so it will be 1 by b minus a into root y, sir.
No, in this case, x 0 to 3, what is p x less than or equal to 2?
It will be 1 by 3 into 2 minus 0.
Yeah, 2 by 3, right? Just don't integrate and all, just look at the interval length. So this is 0 to 3. What is the length of this interval? 0 3 and like, and you are worried about this interval only. Okay, 0 to 2, you are worried about this interval. So what is the length of this interval? This is 2, right? So the probability will be 2 by 3. Okay, so let's say the given function is let's say 5 to 15. So what is the length of this interval? 10, right? And if I have asked what is the probability that x will lie between 7 to 14, then what will be the probability? What is the length of this interval?
7, sir.
7. And what is the total length of interval? 10. So this will be 7 by 10. Okay, but what if I ask what is the probability that x will lie between 5 to 14? Let's say 12. What will be the probability? Let's say 3. What will be the probability then?
9 by 10, sir.
9 by 10. But look at this thing. Here, the 3 x is starting from 5. And let's say 12 is somewhere here. So I'm interested only this interval, not up to this interval. Okay, so because here it is 0 always. So I'm interested into this in this interval only. So what is the length of this interval?
7, sir.
7 by 10. So this is 7 by 10 because it is asking from 3 to 50, 12. So it is same as 5 to 12. Okay, because here it is 0. Okay,
Sir,
so
when we see numbers, we are comfortable, sir. What happens is when we calculate for the y, when we convert x to y, right? So we write.
Yeah. Now
X,
look
so
at this
that
thing. Now
time
look
we
at
get
this
confused.
thing. This is just a number between 0 to 9, right?
Correct, sir.
Why I have taken inside the support of y. Support of y is what? It's just 0 to 9, right?
Correct, sir.
So it is just a point within 0 to 3. Root y will be a point into 0 to 3. That is inside the support of x. So support inside the support of x. What is the probability of that? Just length of that, right? Let's say this is your 0 to 3 root by somewhere here. So what is this length? This is just root by total length root 3. So probability of this will be root 3 by root pi by 3, right?
Sir, but minus root y will also be counted, right?
That I have already excluded. Actually, what I've got from here, I have got that p x square is less than or equal to y, right? The next step I brought minus root y into x is root y, right? But I know that x support of x is 0 to 3. So I have excluded all those points where p of x is 0. So I have just write 0 to x to root y, right? Now my interval becomes is something like that. Here it is 0. Here it is 3. So the PDF is x, PDF of x something like that. So root by somewhere here and minus root by something here, right? So I have excluded these points. I have just counted this length.
So what if we have the x range to be minus 3 to 3?
Yeah, just I will come to that. Then it will be very easy. Okay. So now do two more examples on that. One thing x. So it is clear, right? Any doubts in this part? So what I'm doing, first step is I'm finding the support of y. The second thing, I'm finding the CDF definition. I'm using the CDF definition and converting the definition of y to the definition of x, because what I have is the CDF or the PDF of x. That's why I'm converting the definition of y to the definition of x to find the probabilities. Okay, so this is the method. Okay, so and this is applicable everywhere. Need not to monotonic and all. Any condition is not applied on this. Okay, so now look at one more example where x follows uniform minus 3 to 3, and let's say one more example where x takes uniform minus 3 to 2. Okay. Okay, in this by is what? By is
0
let's
to
say
3.
x square.
0
okay.
to 9.
So what is your support of y?
0 to 9.
Let's say first example. So in this example, it is 0 to 9, right? And in the second case, what is the support of y?
0 to 9.
Again 0 to 9, right? Now I need to find the CDF. The second step is CDF. So what is f of y in the first case? This is same as probability that y is less than or equal to y, right? By I have chosen into 0 to 9. Okay. So this is same as probability that x square is less than or equal to y, right? I've just converted y into the function of x square. Now I can write it as p that minus root y to x root y, right? Now here it is the crucial step. Now look at this y. X support of x is 0 to 3, and y I have chosen into 0 to 9. So minus root y and root y will be inside the support or not?
Yes, sir.
Y I have chosen into 0 to 9. Obviously root y gonna be less than 3, and obviously it will lie with minus root y, and root y will lie between root y will lie between 0 to 3, right? But not minus, right? So I can write it as 0 to x to root y, right?
But
But
x
that
is between
minus is
minus 3
outside,
to
sir.
3.
Okay,
X is
okay.
between
Here,
minus 3
Yeah.
to 3.
here the support is minus 3 to 3, sorry. So here I need not to worry about minus root y, because again minus root y inside the support of x, right?
Yes.
So why I have chosen into 0 to 9? I'm worried about minus root y and root y. Both these points will be inside the support of x, right? So now x is what? Uniform. So I've told you what is the probabilities of this thing.
This one will be 2 root y by 3.
It is something like that. Here it is minus 3, and this is your PDF curve, and somewhere root y here, minus root y here. So what is the length of this thing? 2 root y, right? And what is the total length?
6.
6. So this will be root y by 3. Right? I'm done. This is first case. I'm done with this. Now look at the second case. Second case is bit tricky, but not that hard. Just need to take care of this root y and root y thing here. Now support of y is what? Here my x takes value minus x takes minus 3 to 2. Okay, this is uniform into this thing. Now y is defined as x square. So what is the support of x? Support of y?
0 to 9.
0 to 9. Now the second step is I need to find f of y of y. So what will be this? This is definition. Just use the definition. F of y is less than or equal to by I have chosen into 0 to 9. Okay. Now this will be what? This is just p x square is less than or equal to y. If I will convert into the x, it will be my root y to x to root y, right? Now y I have chosen into 0 to 9, and support of x is minus 3 to 2. Will always minus root by and root by will inside the range of x. By I have taken into 0 to 9.
Root y won't be there, sir.
And x is the support of x is minus 3 to 2. Will minus root y will always be inside the support of x?
Yes, sir.
Yes,
Minus
sir.
root y, yes. Plus won't be.
Minus will always be, but plus root y need not to be inside the support, right? If by I have taken, let's say 9, then root y is 3, right? So this thing is need not to be support of x, because support is restricted to 2 only. So what I will do, I will divide this by into 2 points. First I say, let's say by is between 0 to I need root by 2 less than or equal to 2, right? So I need by to be 4. So whenever by I take between 0 to 4, this definition become minus root y 2x root y. So whenever I've taken by into 0 to 4, this thing is always valid, right? Right? This thing is always valid. It's something like that. It's minus 3 to 2, right? So PDF of x is something like that. Okay, so by I have chosen into 0 to 4, then root y will always will lie into that 0 to 2, right? So minus root to minus somewhere here, minus root y will be somewhere here, and root y will be somewhere here. So this length will be what? 2 root y upon total length will be 5, right? So this is true when y is 0 to 4. What if y is greater than 4? Now my definition changes to this thing, right? P minus root y to x root y. Now look at this point. This point is outside the range, because by I have chosen 4 to 9, then root y is obviously greater than 2, right? So my root, this is your x, PDF of x, this is 2, this is minus 2, minus 3. So root y will go outside 2, right? Somewhere here will be root y. And minus root y will always be less than minus 3, obviously, because it's 0 to 9 only, 4 to 9 only. But I need to I have to take care of this part. I cannot include this part because here probability is 0. So what I will do, I will restrict upper limit to 2 only. So I will do that. Lower limit I have no problem here, but upper limit I will restrict it to the 2 here, up to this point only. So what is the length of this thing now? What is the length of this?
2 plus root y.
Yeah, this length will be your, this is 2 and this is minus root y length. So this will be 2 plus root y, and what is the total length? 5, right? Any problem in this? So always you need to take care of these things. You need to check whether these points are coming inside the support of x or not. Okay, according to you have to change. Because in this case, what happening? So what I did, I divided this by into 2 parts, where by is 0 to 4 and 4 to 9. In this thing, I have no problem. I just calculated the length, because in this case my root y will come inside the support of x. But whenever I goes more than 4, then this upper part goes outside the range of x or support of x. That's why I have restricted the upper limit to the 2 only here. Root y I have restricted to 2. So that length upon total length by 5. So if you do some more questions on that, I think sir has taken in the lecture, and 2 questions are inside in the activity questions, and 1 or 2 questions are in the tutorial questions. You will be practice those questions. It will be easy, right? So any problem?
No, sir.
Okay. So what is left now? Yeah, one thing is about expectation and the variance of thing. So how you define the expectation and variance for a discrete random variable?
Variance is E of x square minus E of x the whole square.
And what is expectation?
Expectation is summation of t.
Your
P of
x is
P of
discrete, so the expectation of x is what? X into p dat x takes value x, and this is summation for all such values, right? Now in the case of continuous, expectation of x is defined as x into we don't define the probabilities, it is always 0, but what we define is f of x, and we just integrate inside the entire support of x. Okay, this is how you define the expectation. And the variance you define as, it is just expectation of x square minus expectation of x to whole square. So what is the expectation of x square? It is just x square f of x d of x inside the support of x. Okay, for any function, let's say g of x. Okay, I need to find the expectation of g of x. So it is what? It is just g of x, the density function of x inside the support of x. Okay, it's true for every function x. Okay, this is how you define the expectation. The variance of x. It is easy now. Yeah, I think most of the part is done now. So if you have any doubts or any questions regarding week 4 content, you can ask. Okay, what is Markov inequality and Chebyshev inequalities?
Chebyshev says if P of x greater than or equal to C is less than or equal to C by sigma square, C square by sigma square.
What is this?
Chebyshev's. If you write it in terms of k, you will get 1 by k square, and inside you have to write k sigma.
So you are saying the p x greater than or equal to c, is it?
Yeah, in C format. Yeah.
No, it's not like that. It is p mod of x minus expectation of x.
X minus mu like greater than or equal to C is
C square,
by
right?
C square.
Or simply you can write p mod of x minus expectation of x greater than or equal to
k sigma
is less than or
equal to 1 by k square.
Less than or equal to 1 by k square. So what is this? This is just the k sigma unit away from the expectation of x. So what is the probability that x will be at least k sigma unit away from the expectation of x, something like that. Here it is expectation of x in the real line. Okay, so this is your k sigma. Let's say this is sigma minus sigma to sigma, and this is minus 2 sigma to sigma. Okay, so somewhere here it is k sigma minus k sigma. So what is the probability that x will lie outside this interval, right? Here or here. So this probability is always less than or equal to 1 by k square. So this is the Chebyshev inequalities and inside this interval will be always this probability is that x minus expectation of x will always be lie inside this interval k sigma. This probability is always greater than or equal to 1 minus 1 by k square, right? Okay, and what is Markov?
P of mu greater than C is
Here in the case of Markov, x should be non-negative. Okay, this is the first point. X should be non-negative, and then p x greater than or equal to c will be less than or equal to
Mu by
mu by c. Mu by c or c square?
Mu by C.
Sir, for Chebyshev's, can it be negative then?
Yeah, for Chebyshev it can be negative. It is mu by c. Okay. So this is Markov.
But why is this condition as in why can't Markov's inequality?
If you look at the proof of this, you will come to know why the this conditions is applied. The proof is given in the week 3 last part. The same proof goes here, but just the summation is changed into the integral part. Okay.
Okay.
Sir, has this formula file been shared in the portal?
Which formula file? Yeah,
The one that you're using?
Yeah, it is shared. Yeah, it is shared. I've taken from the portal itself.
Okay, because it will be a good ready
given in the
reference.
exam also. It will be given in the quiz also. No?
No, it won't be given in the quiz. That formula file will be different in the quiz.
Last time they gave a table, right? So the same.
Yeah, that table will be given to you in the quiz.
Okay.
Okay.
So in the mock also it would be given, because we'll get used to that table then. I mean, I don't know what the table is.
No. In the mock it won't be given. Only in the quiz only.
Okay.
So any doubts in week 4?
So can you solve an example relating to that common method which you explained for a function maybe like mod x?
Which one you are talking about?
We did that method, no sir. Function was x square, and then we took y less than or equal to y, that method. Can we do it like maybe for a different function, mod x?
Yeah, we can do for any functions.
I was trying for that, but I couldn't get the answer.
For mod x you didn't get.
Yes, sir. I was facing some difficulty.
Okay. Let's do one more example. So here, what is your x? Can you give me the example?
1 second, sir.
I think minus 3 to 2.
Yes, sir. It was minus 3 to 2. Yeah.
And y is defined as mod of x, right?
Yes, sir.
So give me the support of y first.
So 0 to 9.
0 to 9. Okay.
Sorry, 0 to 3, sir.
Yeah, sorry, 0 to 3. 0 to 3. Now what will be my next step? I will find the CDF of y. So f of y of y. So y is what? Y is I have defined inside the support of y, that is 0 to 3. Okay. So what is the definition of this? This says that it is the probability that y will be less than or equal to y, right? Now what is my target? I will convert this probability into the probability of x. So y is defined as mod of x is less than or equal to y, right?
Yes, sir.
Now I will convert into the x. So what it means? Mod of x is less than or equal to y means that x is lying between minus y to y, right? Right?
Yes, sir.
I have converted this into the y. I need to take care of these y's. These y are just point within the 0 to 3. Okay, but the range support of x is what? Minus 3 to 2, right? So I need to check whether these y's minus y and y are coming inside the support or not. Look, y I have taken from 0 to 3.
Yes, sir. Minus y will satisfy.
Yeah, minus y is always be inside the support of x. But the support of x is up to 2 only. So whenever I've taken y greater than 2, my that upper limit will go outside the support of x, right?
Yes, sir.
So what I will do, I will take y first inside the 0 to 2, right? Because in this case I have no problem. I can just write it as p minus y x to y. What will be this in this case? In this case, both upper limit and lower limit and upper limit will be inside the support of x. So what will be this probability?
2y by 5.
2y by 5, right? And the next part is y I have taken into 2 to 3. Then this probability, what I will do. Now look at this. I have problem with this limit, right?
Yes, sir.
This upper limit cannot. This upper limit will not be inside the range of x, support of x. So what I will do, I will restrict this upper limit to the which points? 2 only, right? It is something like that. It is x is taking minus 2 to 3 to 2 support of its f, and by I have taken my 2 to 3. So minus root by, minus y somewhere here, y will be somewhere here. Upper limit I will restrict up to 2 only. So now this probability will be what?
2 plus y by
2 plus y by 5, right?
5.
Now I have done every point I have taken. So what will be my CDF of y? F of y will be what? This is 0 when y is less than or equal to 0.
0.
When y is 0 to 3, this will be what?
2y by 5.
And whenever y is 2 to 3,
2 plus y by 5.
2 plus y by 5. And when y is greater than or equal to 3,
0.
1.
Oh, sorry, sir. 1. Yeah, 1.
Can you check whether it is valid or not?
2y. Sir, we'll get 3y plus 2 by 5. Sorry.
Correct.
Is it valid CDF or not? How will you check?
This one is not correct. If it sums to 1 first, and
Sum to 1, okay. Sum to 1 means that when x tends to infinity, f of x tends to 1. When x tends to minus infinity, f of x tends to minus 0. And x is non-decreasing.
correct.
Right?
Sir, I have one question here. So in the previous break that you took, I mean, we did 2 by 5 y, and the next band we did 2 plus y by 5, right? So in the first band also, what we have done is we've taken 0 to 2. Here we are taking y to 2, minus y to 2.
Yes.
So the upper limit in both of them are same. Aren't they overlapping?
No, upper limit. Look, boss. I'm doing here. I'm just choosing I'm fixing a y here inside the support of y. Okay. My support is y is 0 to 3. So what I'm finding, I'm finding f of y here. So let's say, for example, I'm finding values of f of 0, f of 1, f of 2, f of some, for all such points I'm finding values, because there are uncountable points. So I'm just arbitrarily choosing a y inside the support. I'm finding these values. Okay. So for I've taken at y as arbitrarily. So here, whenever I'm taking y into 0 to 2, my probabilities comes like this. Okay. So this probability I need to worry about now. So what is this probability? This is just the
this is 2y by 5. That is understood. That I understood. So in the second probability, what we are doing is we are increasing the y from the left side. We are taking minus y to 2. Minus y to 2 also covers 0 to 2. No? So that is why I was asking.
No. I look here. I'm finding f of, let's say, for here I'm finding f of for example, let's say what is f of 1, and let's say what is f of 2.5. So let's say these are 2 points, f of 1 and f of 2. I need to find out this for y. Okay. So what is f of 1? This is just same as p y is less than or equal to 1, right?
Yes, sir.
So what I'm doing, because I don't have the distribution of y, so I will convert it into the distribution of x. Okay, so for converting this, I will use the definition that y is equal to mod of x. Okay, so y is mod of x means that mod of x is less than or equal to 1. So this is same as -1 to x is less than or equal to 1. So for now, I'm just finding this values and I have converted into this part, right? So this is just 2 by 5. Now look at 2.5. This is 2.5. P by is less than or equal to 2.5. So what is this? This is just same as P mod of x is less than or equal to 2.5, right? So what is this? This is minus 2.5 less than x less than 2.5. Now look at the x here. X cannot take values greater than 2. So I will convert into x less than or equal to 2 because the upper limit up to 2 only. So this is what? This is just 4.5 by 5. Right? So you are saying that some part of here is overlapping into this. But look at this. I'm finding here this thing and here this thing. And I've converted into the x. Whatever x is come, I need not to worry about whether this is overlapping or not. I just need to find this probabilities. That's it.
Okay.
What is this probabilities? Here in this, I just say simple by here. So in the case of instead of 1, here it is just general y inside 0 to 2, right? So I just need to worry about what is this probabilities. That's it, right?
Okay.
I need not to worry about whether they are overlapping or not. Let them overlap. It doesn't matter. I just need to find out this probabilities. I have the distribution of x. I can find easily what is the probability this thing, right? Any doubt?
This one is actually not clear because I also watched the video. Still,
Yeah.
I wanted the clarity, but I think I'll have to look the concept once again and then see.
Yeah, just look at the concept. What I did is I just converted the probabilities of y into the probabilities of x, right? And I have come to this point on now. I've come to this point here, and this is just the definition of x, distribution of x.
What I thought was if the y-axis domain is restricted to till 2, we will only have to calculate till 2 and rest of the probabilities are immaterial because x does not exist in that band. So I thought we will only consider places where x is valid.
Yeah, that's what I did. Here.
So that once only we will, I calculated only once, but we are calculating it twice with the starting point are varying from 0 and minus y. The end point is still within the limits of x. We didn't have a problem with the a lower limit of x at all because -3 was very well included.
Yeah.
Only problem was the upper limit was only till 2.
Upper point.
So I thought we will only consider from -3 to 2, and after 2 it is immaterial. So we will calculate the probability once. But
No. So what will happen in this case if you will restrict the upper limit to 2, let's say minus y. So what will happen? Let's say y have taken 1. Then you have added more probabilities because let's say this is your x -3 to 2, right? So if I'm finding out the probabilities at 1, then it will go from -1 to 1, right? This thing only. But what you have done, you have calculated up to -1 to 2. That's also I don't want. I just want from -1 to 1 only, right? So I have to take care of all the such cases. If I restrict upper limit to 2 for all such cases, then in this case it will wrong because in this case I need just probability from -1 to 1 only. And what you have done, you have calculated from -1 to 2. That I don't want. But so what I did, I just I have divided support of y into 2 parts where y is lying between 2 to -2. Right, in this part, then in this case x will always will lie into support of x, support of y, or support of x, right? But whenever y goes to greater than 2, this part will always be more than 2. So I will restrict it to 2 only. Okay, so you have to take care of all those parts. You cannot directly restrict the upper limit to 2 because in this case, if you will calculate it for y equal to 1, y equal to 0.5 for less than any y less than 2, you will get the wrong answer. Okay. Now you have the CDF. What will be the PDF of this?
Differentiation.
Just differentiation. What is the differentiation of this differentiation? This is 2 by 5.
2 by 5.
And, it is will be 1 by 5, right?
Yes.
And 0 otherwise. Then, okay, so do one or three questions on that. It will be clear.
Okay, sir.
Okay. So any doubts? Okay, so now we can drop up now. So if you have any doubts, you can ask now. Otherwise, you can talk.
No, sir. Thank you.
Okay, so Kartik.